Yeah, good morning to everyone. So, good morning to all. Kindly note down each and every point, not this good morning. The lesson in which we are going to have today is chemical kinetics. So, please write down the chapter name in your notebook as chemical kinetics. Please write down this chapter name called chemical kinetics. It is very important chapter. See, first we have to go with the definition of chemical kinetics. Kindly note down, define chemical kinetics will be the first question in order to understand this particular lesson. It's very important. See, kinetics means in Greek, we used to call it is kinesis, that is nothing but movement. It is movement, remember. So, chemical kinetics is a study of chemistry which deals with the, please write it down, which deals with the mechanism of chemical reaction. So I hope you would have written this same definition. Kindly note down this definition which is important. See, kinesis means it is nothing but movement, I told. That means in chemical kinetics, what is the energy exhibited? It may be asked in 1 marks in JEE and NEET. It is nothing but kinetic energy. Remember this. It is a concept based question. It is a kinetic energy. So chemical kinetics purely deals with kinetic energy. Remember this. So kinesis means movement, and it is a study of chemistry which deals with the mechanism of chemical reaction. So the part 1 of the starting session is over. Next we are going for a reaction like this second part. See here. For example, there is a reactant A and it is going to give the product. There are two important things to be noted here. So this is called as reactant. Please note down in your notebook, this is a reactant. And this one is a product. See, when the time goes on, you can surely say that the reactant is completely going to become into product. Correct? That means, what does that mean? So when the time goes on, the reactant concentration decreases. The concentration will automatically decrease. And what will happen to the product? The product concentration will increase. When it will happen? When the time extends, when the time moves on. So see this concept. When the time goes on, the reactant concentration decreases and the product concentration increases. So when it happens, only if the time is proceeding further and further. So that I can say one formula I can write here. So which is disappearing, the reactant is disappearing. So that I can say rate. Rate means it represents time, remember. Whenever the rate word is coming means it represents time. So rate of, you can write on this, rate of disappearance of R. Why I am writing R? It is called reactant. So that this A I can replace by R. So rate of disappearance of R means it is nothing but A. A is the reactant. That is equal to, you have to write down this formula. The formula is minus dr divided by dt. We can also say like this, minus delta R by delta T. See, this is the first formula. You have to note it down for all the 1 mark question, which is very important. Rate of disappearance. So based on this formula, we are having so many 1 marks in for the board, for the NEET and also for JEE. Only this formula they have asked so many times, minus dr by dt. Remember this. So why we are substituting here minus, that also you should know. Why we are actually giving negative sign? Because when the time goes on, you know very well, the reactant concentration decreases. See, I have written here. Since it is getting decreased, we are writing the symbol here as minus. So now we are going into the third part. Second part is over. What is the third part? It is, the third one is nothing but rate of appearance of P. Rate of appearance of P. P means product. So I can say this one as dP by dt. I can also say it is delta P by delta T. So it is given in plus. You know why we are giving in plus? Because in the product the concentration will be going on increasing. So that is the reason we are giving in plus symbol. So the second part is also over. If you see the graph of this particular, that is the second one, for rate of appearance, let us draw a graph. So you take y-axis and x-axis. You can write down here time and here concentration of product in the y-axis. Concentration of the product. They may give this graph also in the exam. So here the product is increasing. See, it is increasing like this. From 0, it is increasing. It goes on like this, and it will go to an infinity level when the time goes on. So this is very, very important. See, if you take 2 times, so this is concentration, right? So I can take here 2 times like this, 1 and 2 here. 2 important line. So I can take here 2 lines here and here. So here I can take T1 time and here I can take T2 time. Here I can take the 2 values. See, concentration of product I am rubbing here, so that you can write a side here, concentration of the product. So there are 2 important reasons here. So one is P1 with respect to T1 and P2. Now the same formula I can say the average rate, that is I can write like this, average rate. Average rate is equal to, I can write the formula like this, delta P can be written as active mass of P2 minus active mass of P1 divided by delta T is T2 minus T1. Remember this. Note down this formula. So this is an important formula for finding the average rate for of what? Of product. This is a graph for the rate of appearance. It increases from 0 to the maximum. Average rate of product formula is P2 minus P1 divided by T2 minus T1. Now to find the average rate of product or average rate reaction, say what are the 2 important values they will give? They will give 2 product values, 2 concentration values and 2 intervals. If they are giving only one interval, this formula I can also write as P2 minus P1 divided by dt. Remember this. We can also write like this, dt. So I am rubbing here, I am writing here by dt. So now we discussed about the third important one, rate of appearance. And we have to go for rate of disappearance. See, it is here, which has been marked in yellow color. If you see the graph of this, let us write a graph in the same page. So you know what is x-axis, it is time. And you know it is concentration of the reactant. So the graph will decrease like this, it will comes down, it decreases. So I can take 2 values here, 2 intervals, 1 and 2, in which I can take this one as R1 and this one as R2. And 2 time intervals here, this and this. So this is T1 and this is T2. And what is the average rate formula for this? So I can write simply like this, average rate of a reactant is equal to, it is minus dr by dt, right? So we have to put minus here. Here R2 minus R1 divided by T2 minus T1. Remember this important one. So it is R2 minus R1 divided by T2 minus T1. So you have to note down this formula. This formula is very important for cracking 1 marks. So 1, and the next one is I have given here as this one. So there are two formulas, one with respect to the reactant, the other one is with respect to the product. So we have finished. So summary for these three. What is the summary we had now? So summary of this above for the past 10 minutes what I have taken. So the first one is we went with the definition. Just check with your notebook, have you written the definition for chemical kinetics? Then check with the formula of appearance. Formula of appearance. Appearance means it is nothing but product. And also you just check with your notebook, have we written the formula of disappearance? If you are pakka with this, I am very sure that you can crack all the 1 marks with your own effort. No need of any support. Only these three formulas are so important in which you have to remember. Now we are going into the fourth part. What is fourth part? It is generally called as rate of a reaction. Write down this heading, rate of a reaction. We are not talking about the product or especially with reactant how we had. We had a formula for appearance. Now we are writing rate of reaction. So example, to explain this, take down this example in your notebook. That is like this, hydrogen plus iodine gives, I can write as Hi. So to balance it, I can put 2Hi. So it is a liquid solution, it is a gas, it is also a gas. You can also take this one as gas, nothing problem. Everything as in gas. H2 plus I2 gives Hi. Now, in the examination, they will ask you to find the rate of a reaction. Rate of reaction for this. So, this is a 1 mark question. For the board, normally they will give. If you are thorough with the board, then you can easily spark the answer for this question. So, H2 plus I2 gives THI. The question asks is rate of reaction is a question mark. To find the rate of reaction, I can divide into two types. This one is called as reactant. And this one is called as product. So to represent the rate of reaction, now see the solution here, how I am writing. Therefore, rate of reaction. Rate of reaction. The question asks this rate of reaction. I can write minus delta by delta T active mass of hydrogen. See, this is the reactant. We have to put minus. Then put is equal to minus delta by delta T active mass of iodine. The next one. That is equal to. Here 2 is there. You have to write as 1 by 2. 1 by 2 delta by delta T active mass of Hi. This is the rule. Whatever the number is there, we have to take the reciprocal. Remember this. We have to take the reciprocal of that. So it is 1 by 2 delta by delta T Hi. Now you got how to write the rate of a reaction in the form of a formula. Why we are putting minus here? You know very well, minus represents the reactant. Why we are putting plus here? Plus means we can also put plus. Without writing plus also it is called as plus only. So it is increases the concentration of the product. So that's why we are putting minus and plus. Can you able to write one more equation which is part number 5 I am going. Under the part number 4 we are going for the B. A already written. Can you able to write an equation rate of reaction for this? 5Br minus, you can take down this, plus BrO3 minus plus 6H plus gives 3Br2 3H2O. The question asked is, they may ask even in 1 marks, rate of a reaction. The rate of a reaction is a question mark. How to go with the solution? We know to write the solution, it's very easy to go with the rate of reaction. Rate of reaction I can write here. rate of a reaction. So there are 3 reactants, so that I have to put 5 is the number here. I have to put minus 1 by 5 delta by delta T active mass of Br minus. This is first one. The second one is minus BrO3 minus. Then again put is equal to, it is minus 1 by 6 delta by delta T H plus again is equal to is plus, no need to put plus, it is 1 by 3 delta by delta T active mass of Br2. Then finally with is equal to 1 by 3 delta by delta T of H2O active mass. I hope everyone understood this concept. Everyone understood this concept. It's a very important concept. whatever the number is there, we have to take the reciprocal of that. See here, if it is 5, we have taken as 1 by 5. I already told so many times, the purpose of putting minus is, it is a reactant, it is disappearing. I will go with the last one, so you can also do it. I am going with the C, fourth subdivision C. It is fourth subdivision C I am going. Can you able to write this equation in your notebook? For this 2Hi gives H2 plus I2. Can you able to write the rate of reaction for this? Rate of a reaction? Yes, you are right, I think. We have to go with minus 1 by 2 delta by delta T active mass of Hi, then delta by delta T active mass of H2, then finally with delta by delta T, it is active mass of I2. So we have finished the fourth part. What is a summary? Again, I just want to go with the summary of the second one. What is the summary we are going to have? The summary is, we start learning how to find a rate of a reaction when an equation is given. When an equation is given. So this is the summary we had. We want to enclose it for the second part when an equation is given. So summary 1 has been already finished. We went with 3 important points. So summary 1 is, it is definition of chemical kinetics, formula of appearance and formula of disappearance. And the second part is, we are going with the rate of reaction in which an equation is given. It is very easy for us to find the rate of a reaction. So very, very, very important. So let us go with one important sum. So you can just note it down, the first sum. This sum may be asked in board exam and also for NEET and JEE. So now I am just going with the one sum. Take down this question. For the reaction, R gives P. The concentration of the reactant, please note down in your notebook, it's very important. The concentration of the reactant changes from 0.03 m, you know what is m, molarity, to 0.02 m in 25 minutes. Okay. So the question asked is, calculate the average rate of a reaction. Calculate the average rate of a reaction. It's a very important question. It's very, very, very important. See, to find the average rate given with respect to the reactant and also with the product. So now he has given specifically as reactant. So let me go for the solution. Let me write down the given values. What are the given values? The active mass of R1 has been given as 0.03 m. And also active mass of R2 has been given as 0.02 m. and the value of dt has been given, it is 25 minutes. And the question asked is average rate, that is average rate. It's a question mark. Please note down this. Now to go with the average rate of a reactant, so you know very well the formula is minus dr divided by dt. That is nothing but minus active mass of R2 minus active mass of R1 divided by dt. Just tell me what is R2 now. So it is minus 0.02 is the value minus 0.03 divided by 25. Then what will be our answer? So minus, we get minus 0.01 divided by 25. So minus into minus, it's very well known, it is nothing but 0.01 by 25. Now I can write average rate here. I am writing in the left hand side since I am not having space here in the right hand side. I am just going out to the left hand side, that is 0.01 by 25, in which I can write this one as 1 into 10 power minus 2 by 25. Correct. So now I can go with 1 by 25, you can just divide it, or I can also write like this 100 into 10 power minus 4 divided by 25, in which I can strike here for 4 times. It is 4 into 10 power minus 4, 4 into 10 power minus 4. So the unit is, it is mole, remember this unit, liter power minus 1, minute power minus 1. Don't forget to write down this unit. If you are not writing this unit, you will never get full marks. Half mark will be reduced. They may ask in 1 marks also, what is the unit of average rate? So average rate is represented by mole, liter power minus 1, minute power minus 1, or we can also represent, if you want to convert into second, we can convert it. It is mole L minus 1, second power minus 1 also we can give. If you want to convert this answer into second, you can convert it, or we can also give in terms of mole L minus 1, year power minus 1. If you want to convert into year, and also with month, so on. So anyway, but however, I can generally represent like this, mole L minus 1, time minus 1. This is the general representation for average rate. So we have finished with the first question. So one problem we did. I request everyone to do as an activity in your notebook, or not now. I am just changing the sum here. See here, I am just changing the sum as 0.04 m, and here I am just writing 0.02, and instead of 25 minutes, I am giving as 50 minutes. And the question asked is, calculate the average rate of reaction in terms of seconds. No need to do it now, take it as an activity. You do it later. Write down this sum in your notebook. I will wait for 2 minutes to write this question. So just note it down, or otherwise you can, since it will be recorded, so you can see the question afterwards, then after that you can write the answer. So now let us go jump on to the next important heading, that is we went with one sum and we are going into the next division, that is we went with the fourth one and we are going into the fifth part. What is that fifth part? That is rate expression and rate law. It's very important. Rate law is very, very, very important. Rate expression and rate law. So this particular part you have to remember. Rate expression is a rate law is a heading given in the subdivision number 5. Please note it down, this heading. See, for example, if I am going to give an equation like this, XA plus YB gives product. How to express the rate? So rate expression, see here, rate expression. There is a formula for finding the rate expression. Rate expression is directly proportional to the active mass of A into active mass of B. You should not put plus here. If there is a plus in the given equation, we have to convert into multiplication. So this is the way of expressing a rate for a given equation. And what is there as a mole, you have to represent in the power. Remember, Clear? That is a power x, b power y. Can able to give rate expression, and also for rate law also we'll finish it out. So rate law. So rate law. How to write down the rate law for this? See, now to find the rate expression with respect to the reactant we did. This is called reactant. Say reactant rate we normally used to represent like this, minus dr by dt. Already I have told why we are putting minus. It is because of the reactant. It is directly proportional to active mass of a power x, active mass of b power y. This is the rate law in which you have to write. So that implies minus the dr by dt, we have to introduce a constant called k. It is a power x and b power y. That's all. We have finished. So we know how to write the rate expression, we know how to write the rate law. Shall we go for one more example to explain this rate expression and rate law? Yeah, let us go for an equation like this. It is Hi gives H2 plus I2. This is balance is 2. Can able to write down the rate expression for this? Rate expression. Rate expression is directly proportional to what? It is Hi. What is there in the mole? It has to be written here too. That's all. So this will not be used. Then how to find rate law? Rate law is nothing but to find the rate law, you have to put minus dr by dt. Correct? It is directly proportional to Hi the whole square. Then if you put minus dr by dt, I can put is equal to, and I can insert a constant called k, Hi the whole square. I hope you got it. Finished. We have finished the writing the rate law also. So the summary of 5 is finding rate expression and rate law. So part number 5 is over. We have taken as a part number 1, 2, 3, 4, 5. We have finished part number 5. Still 30 minutes more, we can finish this lesson. So now we are going for part number 6, note it down. Part number 6 in this lesson. So part number 6 is, let us go for writing the heading called order of a reaction, which is very important. Order of a reaction. See, if there is example, to go with the definition of order, let me write one equation like this. The rate is equal to k into a power active mass of power x, active mass of power y. If a reaction is given like this, in the examination, if they are asking what is order of a reaction, then what will be your answer? For that we should know the concept, right? If you want to find the order of the reaction, it's very easy. See the power, what are the two powers given in the reactant side? It is x and y. Then just add the sum of these powers. So order of the reaction is nothing but it is x plus y. That's all. Finish. Now how to define then order of a reaction? So order of a reaction, this definition is very important for the present plus 2 students. You have to note down this, a definition for this. It is defined as the sum of the powers of the concentration of the reactant. It's a very important. Sum of the powers of the concentration of the reactant. Please note down this very important point. Defined as the sum of the powers of the concentration of the reactant in the rate law expression. Because we are expressing in the rate law, right? In the rate law expression. So part number 6 is over. The summary of part number is we are going to find the order of the reaction. There are some problems based on order of a reaction. So let us go with some problems. Say just 1 marks problem. So I hope you would have written this. So I'll go with one sum. In part number 6, we are going with a sum A. So let me write an equation. Rate is equal to K into active mass of A power 1 by 2, active mass of B power 3 by 2. What is the question asked? The question asked is order of a reaction is dash. Order of a reaction is dash. This is the question mark. How to go ahead with the order of reaction? How to go ahead with the order of the reaction? Balaji, I think you would have got the answer, even Vishal. Yes, you are right, Balaji. You are correct. So, the order of reaction is, we have to add the powers 1 by 2 plus 3 by 2. You get 4 by 2. That is equal to 2. So, this is your answer. It's very easy now to find the order of the reaction. Let me go ahead with the B question. Can you able to find the answer for this? I think Rupa is there in the line, and so many of our students are there. Sanjay is there. So, let me give this equation. It is K into A power 3 by 2, B power minus 1. Can you able to find the order of the reaction for this? I hope you would have got the answer now. So, anyone in the comment area who got the answer, can you able to comment it? Anyone waiting for your comment? Yes. Anyone? What is the answer? Can you able to say me? As waiting for the answer? Yes. It is nothing but 3 by 2 minus 1. We get 3 minus 2 by 2. It is 1 by 2. So, the order of a reaction is 1 by 2. So, we went with part number 6, going with some sums, finding the order of a reaction. Now, we are going for part number 7. Part number 7. What is this part number 7? So, let us go for the heading. To find the types of order of reaction. Types of order of reaction, which is very important. See, there are so many types of order reaction. We can start with the first one is zero order reaction. There is one reaction called zero order reaction. And we can go with the next number. You know, what is the number after 0? Yes, you are right. It is first order reaction. Then what is the next one? It is second order reaction. It is second order reaction. It goes on. Third, fourth, fifth and all. See, if you just know the definition of these first 3, remaining you can write of your own. So, now let us go for finding the definition for zero order reaction. Definition of zero order reaction. For the first one, for this one, zero order reaction. See, we know what is the order of a reaction. Already we have written. I just want to go back. See, order of the reaction is sum of the powers of the concentration of the reactant in the rate expression is called order of reaction. If it is zero order reaction, so that I can write here, it is defined as the, I am writing the definition, you can also write in your notebook. It is defined as the sum of the powers of the concentration, sum of the powers of the concentration of the reactant, sum of the powers of the concentration of the reactant in the rate law expression is 0. In the rate law expression is 0. Then we used to call it as a zero order reaction. If it is 0, it is zero order reaction. So, now we got the definition for zero order reaction. Zero order reaction. So, the unit of, remember this, the unit of zero order reaction they will ask here as mole L minus 1, S minus 1. Remember this, mole L minus 1, S minus 1. This is very important to be noted always, the unit of zero order reaction. Then we are going for, I am just rubbing this 0 order now, and I am writing here the definition as first order. For the first order, the same definition, what we are going to do is, I am just removing the 0 and I am writing the sum of the power of the concentration is 1. And also the unit you have to remember for the first order. The first order unit is 1 by S. 1 by S or S power minus 1. Both are correct. Second power minus 1. Remember this important unit in which you have to note it down. And finally with, I hope you would have finished this. You can write off your own. The only thing is you have to change the values here. For 0 order it is 0, for first order it is 1. So now I hope you can write yourself, it is a second order. For second order, the answer will be 2. So here I am writing here as 2. And you have to remember the unit. So what is the unit for a second order reaction? It is mole minus 1, L, S minus 1. Remember this. Mole power minus 1, L, S minus 1. So we wrote 3 units, right? First for 0 order, for the first order, and the second order. I just want to summarize again units. For the 0 order, it is mole, L minus 1, S minus 1. Remember this. For the first order, it is S power minus 1. For the second order, it is mole minus 1, L, S minus 1. It's enough. This you have to remember. Now we are going for an important thing. So still some 20 minutes is there. We can finish off this lesson. So now we are going in the important question. That is, I think it is part number 8, I think. So we are going into the part number 8. So part number 8. As a question you can write down, derive an expression. You can write down as a question. Derive an expression. Based on this, there are so many sums for you to do. Derive an expression for finding rate constant of a 0 order reaction. It's a very important question. It's a very, very important question. Remember, 0 order reaction. So this is a question. It's a very important one. It's a very, very important one. See, let me revise this again. Let us consider, for some of the students I already taken this, even though it's a revision for them. The students who are attending new, so it's very important for them to remember this. Let us consider the 0 order reaction as follows. As follows. So let us take a reaction like this. A gives product. Write down this. Or you can also write as, instead of A, I can write as or. It is better. Or gives product. See, now I can applying rate law. Applying rate law. We get, what is rate law? We used to write down as minus dr by dt. If it is rate law, means you have to write minus dr by dt. It is directly proportional to this R, this reactant. There is no number here. If there is a number, we would have substituted here 2 or 3. 0 order reaction concentration is 0, so that I have to write only 0 here. Why I am writing 0? Because it is a 0 order reaction. The power is 0. That's why I am writing here as 0. What will be the next step? Minus dr by dt. If I am going to put is equal to, I have to put a constant k. I can write into 1, because anything to the power 0 is always 1. You know very well. It is always 1. So cross multiplying, I can write minus dr will be equal to k dt. There is no doubt. So take this minus to that side. we get dr will be equal to k into dt minus k dt. Integrating on both sides, we get r is equal to here kt minus kt plus c. C is a rule for integration, you know very well. You know how to integrate dr, you know how to integrate dt. See, if you talk about initial condition, initially, the time is always taken as 0. It's a condition. Whenever, if you're talking about initially in terms of chemistry or in physics, we used to take initial time is always as 0. This is a common term. And R, I don't know how will be the shape of R, amount of R. I'm going to take this one as R naught. R naught, initial one, initial reactant. Not as R power naught, it is R naught, suffix we have to write. If you substitute this condition here, I will get R naught is equal to T is 0, so that I will get 0 here plus C. So the C will be equal to R naught. So this is equation number 2. Equation number 2. I can go with the substitution here 2 with 1. So I will get active mass of R is equal to minus KT plus R naught. So I can write minus KT, you can take this side and R to this side. So I can write like this, KT will become equal to R naught minus R. Then again, if you want K, it is R naught minus R divided by T. It's a very important formula for zero order constant. So this is an expression for zero order rate constant. So remember this formula as a summary after finishing this particular part. See this, note down this, remember this. Then there are 3 values given for you to go with the problem. What are the values? They will be giving initial reactant, final reactant and time. If they are giving 3 parameters, it's very easy for you to find the zero order constant. It's a very, very important one as a derivation and also with respect to the problem is concerned. So the most of the NEET questions they are asking only from this zero order reaction. Remember this formula. So what are the 3 parameters they will give? K is equal to R naught minus R by T. From this we can write so many formulas like Inky Ponkys. So if you want to find a T, example I am writing here, I can write R naught minus R divided by K. This also you should note it down. If they are asking just time, that is time of a zero order reaction to be completed. Time of a zero order reaction to be completed, which is very, very important. It's a very important one. So now we are going with the part number 9. So part number 9, still 15 minutes more. Part number 9 is, it is off-life period of a zero order reaction. Note down. Off-life period of a zero order reaction. It's a very important one. We are going into the part number 9. Part number 9. See, first we should know what is off-life period. See, you should know write the definition of this. Off-life period means it is nothing but the time. Is defined as the time taken. Please note down this in your notebook. It is defined as a time taken for the 50% completion of the reaction, which is very important. %50 completion of the reaction. There is a condition for off-life period. What is that? For off-life period, see the time symbol will be changed. For T we have taken, this will become T off. Am I right? And also, the value of R will become off of the value. That is like this, R naught by 2. So remember this condition. They may ask in 1 mark these conditions. So this is this one, especially this one. It will become off of the value. If there is 100 gram initially, then what will be the off-life product reactant? It will become off, that is 50 gram. Now we can substitute here in this formula. What is that formula? It is K is equal to, I just want to remember this formula. It is R naught minus R divided by T. See here, I have written here. Now I am changing this one as half life as T off and R as R naught by 2. See here I changed it. Now we will replace this T off and K like this. T off will be equal to 2 into R naught minus R naught divided by 2K. So finally, I am ending with half-life period of a zero order reaction is, it is R naught divided by 2K. Remember this formula. They may ask in 1 marks the same formula itself. It is T off is equal to R naught by 2K. So we have ended with part number 9. We have finished half-life period of a zero order reaction. Then we are going for part number 10. Write down as a question. Derive an expression, another expression. Derive an expression for a first order constant. For a first order constant. So let us go with the solutions. Let us consider, write down this. Let us consider the first order reaction. If you are cleanly observing a class, I hope you can finish this lesson. Let us consider the first order reaction as follows. So that is A gives product. So we have not taken as A. We have taken as R gives product. Can you able to apply the rate law for this? Applying rate law, we know very well. Applying rate law, we get, what is that rate law? So it is minus dr by dt. It is directly proportional to R, active mass power 1. Why we are putting 1 here? It is a first order reaction. Then the next step, minus the dr by dt, I can introduce the value of K constant if you are removing the proportionality, active mass of R. Then I can take to R one side, minus dr by R, active mass is equal to K into dt. K into dt. Then after that you know what to do. So we are going to take an integration. So you take this minus that side. So integration dr by R will be equal to minus K integration of dt. Dr by R is nothing but log base C you have to write, which is also called as ln. We can write as ln R or we can write log base C, or it's always better to write like this, minus Kt plus C. Take it as equation number 1. Then initially, you know the condition. What is the condition initially, my dear Sushmita, Ashwini, you are there in the line, and what will be the initial condition? I hope you know very well the initial condition is T is equal to 0. And the value of R is taken as R naught. If you apply this condition, we get log base C R naught will be equal to C, because T will become 0. Equation number 2. Let me substitute 2 in 1. If you are substituting 2 in 1, we get, what is the equation we get? We get log base C R we get is equal to minus Kt plus log base C R naught we get. Take this minus Kt this side and log base C R this side. So we get Kt is equal to log base C R naught minus log base C R. You know the formula for log A minus log B. The formula for log A minus log B, it is log A by B. It is log A by B. Then I can write Kt is equal to log base C R naught by R. This is active mass. To convert log base C into log base 10, we have to multiply by 2.303. It's a rule. To convert this log base C into log base 10, I have to multiply by 2.303. Correct? And here log base 10 I can convert. R naught by R. Then if you want to find the value of K, it is 2.303 divided by T log R naught by R. So this is an equation for first order constant. You have to remember this as a formula to go for solving so many sums. So this is an important formula to be noted. K is equal to 2.303 log R naught by R. So we have ended with Roman letter number 10. And we are finally going with Roman letter number 11. What is that? Off-life period of a first order reaction. You know the definition for off-life period. It is defined as a time taken for 50% completion of the reaction. So what is the formula we have written in blue color? See here. Now for what is the condition for off-life period? So we have to substitute T as T of and R as R naught by 2. You substitute here K is equal to 2.303 by T of log R naught I am writing as it is divided by R naught by 2. Write down this. Write down this. You can cancel this R naught and 2 can be taken to the top. So K will be equal to 2.303 by T of, it is log 2. It is log 2. See the value of log 2 and we can interchange this T of and K here like this. T of is equal to 2.303 by K and log 2 values it is 0.3010. If you multiply these two, we get T of is equal to 0.693 divided by K. So it's a very important formula to be noted for, especially for 1 marks. Remember this, don't ever forget. Please note down this. Very, very important formula. We have finished off-life period 2. So finally, we are having still 6 more minutes. I'm finishing this lesson, all the concepts. So we are going with the last topic, which is called as 12th one, Arrhenius rate constant, Arrhenius equation. Arrhenius equation to find rate constant. The last part of this lesson. Remaining everything after this, everything is deleted as per the new circular is concerned for CBSE. Arrhenius equation to find rate constant. The same thing is there for state board also. The same thing, whatever we have there, it is there in CBSE, it is applied for state board also. So you know what is rate constant symbol? It is nothing but K. Arrhenius found a mathematical equation for finding rate constant as K is equal to A e power minus EA by RT. This is very, very important. Remember this. Minus EA by RT. So what is A? What is K? K is called rate constant. You have to write this. That is very important. K is called rate constant. What is EA? It is called activation energy. What is R? It is rate constant. What is T? It is here temperature, not time. Temperature in Kelvin. That's all. So finally, To go with the further expression if you want, you can, since it is in power term exponential, we can take log on both sides. That also you should know how to take log. So by taking log, I can take like this, log k is equal to log a e power minus ea by rt, in which I can split this particular logarithm like this. Log k is equal to log a plus log e power minus ea by rt. Remember this. By using power rule, I can take this minus ea to the front. So log k will be equal to log a minus ea by rt log e. Log e. Minus ea by rt log e. Remember this. And log e to convert into base 10, and it will become log base e. See, it is actually 10 here. So to convert this log base e, so we can write a formula minus ea by 2 point, not multiplying here because we are converting log base 10 to log base e. That means we have to divide here by rt. So this is the formula we got. It's a very important one. See, if you are taking two trials, there is two rate constant like this log k1 for example. If you are writing like this log a minus ea by 2.303, I can take the temperature as T1. This is for the first case. You know how to write the second case, Balaji? It is nothing but log k2 is equal to log a minus ea divided by 2.303 RT2. For the calculation purpose, if you divide like this, sorry, subtract like this, log k2 minus log k1, if you're going for the subtraction for the two trials, we can cancel this log a and log a. See, if you're subtracting from here to here, this will become plus. So I can write like this ea by 2.303 RT1 minus ea divided by 2.303 RT2. Log k2 minus log k1 is in the form of log a by b. I can write log k2 by k1. I can take common as ea by 2.303 r, which is nothing but 1 by t1 minus 1 by t2. So finally, I can go ahead with this log k2 by k1 is equal to ea by 2.303 r. It is nothing but T2 minus T1 by T1 into T2. We finished all the concepts of chemical kinetics. See, after this, whatever it is there in the book, it is deleted. So only up to this, as per the new portion is concerned. So you studied up to the Roman letter number 12. So to summarize, there are 12 Roman letters. So exactly it is 11 a.m. We have finished all the particular theory part and some sums, only one sums we did. And in the next live class, we are going to do some important sums which is going to happen, which is going to come for NEET and JEE and also for the CBSE board. And thank you very much for being with me today. It's a great session we had. So totally some 18 to 19 members they attended. Now it is 24. So thank you for being with me. Again, we are going to meet in the next session for the same lesson for doing the sums. Until then, bye from you. Bye-bye. See you.